our guests here, Michael Kammes, of course, Pierre, Jasmin from Revision Effects. I am Gary Adcock. But you know, we try to define what this stuff is, and I have fun with it. I like to remind people that every time you did one of these, and you talked about, you know, are you a robot? Guess what?
Yeah.
You were teaching robots how to see what the images are. Anytime you ever did that, you're teaching robots. So if, you know, it says, what's a bus, what's a crosswalk, all those things. We've all done this capture stuff. That's been teaching machines how to see. They've been using our visual cortex and our information to teach machines to see. So, and then what you get into is stuff like, you know, I really need to understand how images see. It's the dog and muffins there. So there's only like 4 slides here. I'm not going to do this. How do you teach machines to see? This is actually a really good image on how you explain to a computer what is what. How you teach them how to understand. How you teach them to know. And then you get, you know, the flip side of it where it's trying to build things on its own. This is the evil chat GPT version. But literally we're talking about code, augmented intelligence. And from that, I want to kind of go, let you guys like give some information and tell me what you think about all of this. Pierre, why don't you start?
I've been doing visual effects for all my life, in the last 25 years as Revision Effects, which is a company I started. And we've been working on our own AI framework for a number of years. And we're very not concerned by certain things happening. Because we develop tools, and the important thing for us is control and accuracy. We also deal with video, right? Mm-hmm. So, which is a constraint on the problem in terms of you want things that are stable over time, that doesn't flicker and stuff like that. So by control, I mean you work on a problem, you want to tweak the result to your purpose. And what I'm going to show you is related to using machine learning for getting more accuracy in what we've been traditionally doing, like trying to merge computer graphics, image processing, computer vision, for getting more precise. So there's different, if you break down our traditional problem of dealing with video, right? There are things like upscaling that have a clear ground truth, because you can scale down an image and you have a reference to know if your result is what it should be or not. So the training can be is much more simple. There are things like segmentation that might involve a human in the loop for training. I know like Facebook, for example, spent a lot of money on people actually making maths and stuff like that. And as well, they used a lot of this process they call mechanical Turk, which is hiring people on the internet and stuff like that. And the problem is, if you pay people by the image, their lifetime is about 30 minutes. After that, they become not reliable because they just want to make more money, so they go faster. There are things like noise reduction that people simulate by adding noise to an image, or something like that. Again, if you stay in the domain of things that are where you have an explicit ground truth, that you can use machine learning to improve your traditional tools in isolated part and stuff like that, improve accuracy or improve performance and stuff like that. So we've been, our first experiments was, before I go there, there's multiple frameworks around the world that people use, like use word like PyTorch or TensorFlow, or I know Gary worked with Vino from Intel and stuff like that. And Apple has their own thing. There's this thing that Facebook and Microsoft worked on called ONNX that tries to make converter from those different things. And we actually now use the OpenCV one because it supports all those models. We had the internal problem ourselves that each developer is more familiar with one environment and stuff like that. So I just put this picture. A model, that's what the model looks like. It's a bunch of little operator inside of a graph, right? So I'm going to talk just about two little things. One is about two examples. One is about resolution enhancement. We already have a product called ResUp for improving the resolution, and then our latest experience in tracking and matching using machine learning and getting a lot more accuracy. And so when it's not just about using AI for using AI, it's also, is it better than what we currently use? And can you measure that? And so the reference for image resizing I'm the most interested in is the Lanczos filter, right? Am I always better, never worse? And am I usually substantially better? And the same thing with tracking. All the photogrammetry work and stuff like that, as all for the last 20 years, is all based on SIFT and stuff like that. We've been historically avoiding that because it was patent. We use other framework, but now it's very promising what we can do. So again, I was saying the problem of resizing is here. So I have videos if we have time, but I'm trying to see, am I going to do better than a traditional resizer that's this time it's 2x and stuff like that, or not? So, and I've used this sort of footage from something the ASC built. I didn't bring my mouse. Where's my cursor? Yeah.
It's on the other screen.
Yeah, sorry. So one thing I realized playing with footage like that, if you're, it's part of the process, right? So a lot of the shots
they can't see that.
Oh, they can't see it. Sorry. Here you go.
Go ahead and close your PowerPoint. We'll just talk after this.
Okay. Well, I'll finish the PowerPoint instead. And where am I cursor? Sorry.
Well, while you're messing with it, Michael, let's talk about it from the other side.
Yeah.
You know, you're an end user. You're the kind of person who I wouldn't stand in front of the speaker.
Yeah.
So you're like me. You're one of these ones. Rather than being a programmer or anything, you're an end user. You're seeking out the knowledge that's there and what we can do. What are some of the things you're seeing in machine learning and how it works? What are some of the things that you've been playing with that you keep thinking about?
There's two.
Pierre is very definitely a developer trying to build things on it, and we're on the other end of just the creative side and everything.
So just to finish that, and I can show you a video after if we have time and stuff like that. So this is what I'm doing is, see there's 4x of difference between the point of view here. Mm-hmm. Right? It's actually shot on an iPhone with the Filmic Pro, little utility. And with SIFT, when you get to that type of difference, I get like maybe 40, 50 points that I can match. And that's the best thing out there. And our thing where did it go? Sorry, now I switched the slides. Here we go. We can now get about 1,500 points.
So that's the pattern you get to start building the machine learning.
Yeah, so that's improvement in accuracy, right? Which means I can do now seamless zoom from one to the other, like view morphing with very, with very dramatic baseline difference. Which I could never do before. So a lot of the traditional thing you think in your head historically and you keep on trying and never works, now are starting to work. And it's still the same, still the same tool, like just changing the building blocks inside of it or something like that.
So back to you, Michael. Talk about how you got started into what you're doing. And we'll talk more about the art and everything of it. The programming, as you can see, can get pretty complicated pretty quickly.
Yeah.
So,
I'll take this in a little bit of a different direction because,
Yeah.
you know, for years we've been covering this, but it had the really unsexy name of cognitive services.
So,
That's what it was called, and if we just called it AI from day one, probably would have had more interest in it.
there, guys. All right, this one.
Here you go.
But so what I find very interesting is that there's two questions I get asked on a daily basis, and that's, is AI going to take my job? What can AI do today? And the third one is, how can I do it myself, right? I don't want to have to pay ChatGPT. I don't want to have to pay that. I don't have to pay for how many tokens or how many responses or how many characters I can get. So the first thing is that, is it going to take your job? Not anytime soon. We haven't even mapped. I was talking to the VP of Architecture and Technology at Avid. He used to do medical science as well. And he said, we haven't mapped 10% of the brain, let alone, and if we can't map 10% of the brain, how the hell are we going to develop AI that's better than our brain, right? So one of the things that was brought up is that right now, it's the things you don't like to do. That's what AI is going to be able to do. So I know this is very much DP based, but we talk about post-production, we're talking about localization, we're talking about language versioning, then it comes to swapping out languages, then it comes to morphing the mouths to match those languages, to changing voices, to doing voice cloning, so those things. What you're going to see from the generative AI in terms of images is right now, it's an aesthetic. And from now for a while, is that anything that's generated by Stable Diffusion or anything like it, it's going to be an aesthetic. And I don't mean 20 fingers, I don't mean 100 teeth. I mean the stuff that's being generated is going to be kind of like how editing was in the 90s, right? Let's do Dutch angles and let's do quick cuts, right? Let's have a lot of flashing lights. It's going to be an aesthetic. And right now, generative AI for video is extraordinarily difficult. Generating one image, that already takes an immense amount of processing, but now you have to create another one. And right now what's being done is they create one image, then another, and then they morph the two. That's not motion video, right? That's ugly. And so
it's animation.
It's well, yeah, do it on the twos and you'll be fine. So we are a ways away from that being commercially accessible. But what that leads to is, if I want to do it myself, what do? Do I get yet another subscription? And I'm paying somebody $30 a month to do that? Or the dream that I have, and I think a lot of others have, is the ability to localize that, right? To take a base model and then fine tune it, right? So it's almost like, how many of you used to have encyclopedias as a kid, right? Okay, so that's what we're almost looking at, because models can be so immensely large and so taxing on a local system, is that you're going to start to see the text layer of kind of ChatGPT, right? What's taking your natural language and then converting that into something that can, parse that model. You're going to see that kind of chat interface, but then you're going to see purpose-built models. And those models will be like one of your editions of an encyclopedia, right? It's going to cover that small subsection. Because when you start trying to index and create influences from everything, that data set becomes 65 billion data objects or more that your computer can't run unless you're paying the cloud several dollars an hour, even more, to power that. So some of the things that we've been looking into are commercially available. I'm going to mispronounce the name, but has anyone heard of Unga Bunga? Yeah? Unga Bunga? Okay. How many of you surf GitHub at all? A little bit? Okay. GitHub's great. There's a repo called Unga Bunga that you download. It turns your local system into a model reader that you can then interact with a chat-like GPT interface. So there are pre-built models. Has anyone ever gone to Hugging Face? Yes, okay, Hugging Face. Free models to download. So Unga Bunga allows you to download predefined models for anything from 17th century photography, right, to 90s music videos, right? People are training these libraries. You can then download those libraries, load them into this interface that you run on your local system, and that enables you to say, I want to create this text, or I want to create this image. There's even a Stable Diffusion version, Stable Diffusion 1.5. You could localize that model. The problem there is that you still need to be what we call a prompt jockey, right? How am I going to ask this question in the right way that this ChatGPT text layer, and I'm using ChatGPT just as a common parlance, right? What we're all talking about is basic text to what the computer understands. It's going to be a mix of finding the right models that you want to emulate for that video or for that picture. Right now, it's still relatively expensive, right? One of the top consumer graphic cards is NVIDIA 470 or 480, right? 470 Ti runs about $800. That's not too bad. So you could download that. You could buy that, put that in your system, and use that to process. But then you still need to learn how to be a prompt jockey, and not only that, but what are you typing in the command line to further optimize how that's run. So what we're gonna start to see in the next couple of months, because every time we use a tool, 2 weeks later it's obsolete and there's another one.
There's a new tool, it's updated.
You're gonna start to see more models that are more user-friendly and that are gonna have these options to further optimize these models. And so it's gonna become incumbent on you, if you want to use AI and ML to generate images that you want, you'll need to download the models that have that influence, that someone's trained. Or what you do is you get a basic pre-trained model, and then what you do is you what they call update the embeddings. You're fine-tuning them, right? That's what's done with a lot of face swaps, right? I can certainly do 10,000 images of one person A and person B, but there's a commonality between a lot of that. So you get a pre-trained model on just faces in general, and then you refine it with each person. So this could become a tool in your tool belt for pre-visualization, right? You can take your own images that you've shot, video that you've already shot, fine-tune a model that already has those base images, and now you're creating storyboards, right? So there are all these tools, but unfortunately you're gonna have to learn these and do it a little bit on your own. The reason being is right now there's a lot of lawsuits regarding code being scanned that permission wasn't given. And so you're gonna start to see the cottage industry of pre-trained models that you'll have to buy or most likely rent. So people will be trading models based on their own data and then saying, this is my good data, you can't have it, but for 20 bucks a month you can.
Like stock footage, stock assets.
It's the unreal marketplace.
Yeah.
I mean, and that's the interesting part about this too, is because all of us see this differently in how the progression of these models work. I mean, when you start working in the LLM, large language models, and how this predictive comes up, and the reuse of those, and it's actually understanding of it. How many people, let's just ask the question, how many people have heard of Wonder Dynamics? Yeah. Luma AI, if you're doing any Nerf stuff. Anybody working in Nerf? Nerf is a whole part of this too. So, yeah, I knew you'd be here. I'm trying to think of Fireflies. Anybody in the Firefly beta? So, I mean, all of these things are parts of what they're doing to kind of streamline the process. And of course, we got Midjourney and ChatGPT and Bard and OpenAI.
Runway is a good example of something that tries to think like an application, as opposed to some random technology that's out there that you.
Yeah, and it's interesting because the more we feed this, the more it grows on itself. I kind of laugh. Everybody talks about the two chatbots that said to each other, and then after a while they were like the two Muppets in the balcony bitching at each other, and that's what it is. And the generative AI part of this is rather interesting, in the fact that it can build its own models and do things, and you can program it to do everything else. But that doesn't mean that it's it's sentient. It's not Skynet, and luckily the robot models are not done yet. But the reality of it is that we're trying to figure out ways to do this. I think about things like copyright for my personal work, plus the things I generate, and how that's going to work in the future. How are we going to be able to maintain copyright? How are we going to maintain ownership and authorship of this?
So the context I have is a lot of people that put things in Creative Commons with attribution. We're doing it for self-promoting their own work or something like that. That's like the fuzzy one here.
And that's an interesting part about this, because that's true. You do treat it like that. You do need to have that attributions. And a lot of them is, Adobe, many of the military things, Google have already started building AI searching tools that'll actually tell you when something's been articulated like that. It's kind of interesting to see that. And in the environment we're in, we need to do that. I mean, how many people in here are worried about copyright and protecting their own data? All of you should be raising your hand if you're thinking about developing this, because copyright doesn't only cover the image you make, it covers the code you put in to make it. Code is there. Yeah. Right.
How many of you sign a contract before you work, before you go on set? Okay. One thing that's been discussed quite heavily, and it got press a few months ago, Keanu Reeves, right, had written into his contract that you can't digitally manipulate me. I know I'm botching the exact phrasing, but it was, I can't be digitally manipulated, XYZ. And so one of the things we've talked about is in each discipline in pre-production, production, and post-production is write that into your contract. This cannot be digitally manipulated without my sign off. Now, again, all of you have a color pass that's being done, right? All of you are having things done already, but what we're waiting for is some kind of verbiage that outlines this can be done, but not to this extreme without my express consent.
Well, the other thing I've run across too is University of Chicago, where I'm at and Michael is from. Their science department came up with, AI department came up with an application called Glaze, G-L-A-Z-E. Now, Glaze is an application.
No wonder you like that, Gary.
Yeah,
it's food.
Food and everything else. Yeah. And you run your app, you run your image through this before you post it online. And basically what it does is it puts a generative front on it that masks the metadata that allows the AI to actually take the image, and it limits it. It's more like, you know, the old HDCP controls on something. It's kind of like, oh yeah, you can see this and you can touch it, but you can't do anything. I can't put it anywhere else. So it's kind of like a digital HDCP like link on it. And that's the fascinating too, because there's a number of manufacturers, Google included, Amazon also, are building tools to find out what is AI and what's not. And we have to worry about that. We've got to worry about bad actors. You know, it's not always Pope in a coat, you know, in a big puffy coat. So
the thing that I'm very unhappy about, and I think we've been failed, is the promise of blockchain. The promise of blockchain was supposed to be a way to track things from beginning to the end. And in some markets, it has varying degrees of success. We'll leave it right there. But right now, we do not have a way of verifying something that was acquired, went through post, who did it, who may have used it, if it was manipulated in certain ways, and then out to distribution with a way to track that. And unfortunately, there is no technology right now that is ready to ship, that is ready for widespread, that the camera companies have adopted to do that. And because of that, it falls on us to use bespoke methods to actually ensure that our content, the quality is maintained so we don't have those bad actors.
You actually think metadata is going to pass from camera to post?
No, well, what I'm talking about is not just the empirical metadata. Right.
I know.
Okay.
But I use mine as a reference because it's literally, I mean, we fought for metadata for years and trying to get metadata to do what we want it to do, and it doesn't. And I find that really interesting. It's like, why am I echoing so much? But that's the interesting part about this too, is that we're now at this point. Question, JP.
I was wondering, some blockchain ledger, where they fire the actor, ADR is flying, they're still flying in with, you know, the tapes with
Yeah.
and
Transport.
there's still that, but what do you imagine being frustrated by that? What would be something like asking that?
Sure. Well, the problem with standards is that everyone has a standard, and you need people to adopt those standards, right? What it's going to take, and unfortunately, and Gary can speak to this more than I can, is that when it comes to camera life cycles, right? Just like, let's talk about camera to cloud, right? Camera to cloud, great idea. Wasn't a new idea, but it was a great idea, but it took several camera iterations, for the back office paperwork to get done, but for the technology to be built so the camera can actually do that relatively easy. So when we look at things that are injecting some kind of either metadata or something forensic in the background, that has to be built into the camera. And since there isn't a standard on what that metadata or forensic watermark is, no one's gonna spend the R&D money to do that when there is no blockchain or nothing else to track that. So until there's a standard, I've talked to some folks, certain company that makes tablets, right? And they said, well, people who are using their own tablets with their own stylus, those are all unique. Why don't we have a unique ID to that stylus, and then we can track whoever's used that stylus, that metadata of that serial number is then embedded in there. That's great, but we're halfway through the production and post pipeline at that point, right? And forgive me for getting on a tangent here, but and I'm not going to get political, but what we're going to see a shit show of at the next election is face swapping and deep fakes becoming more and more accessible inside your editing tool set. So instead of using some skunkworks project written overseas that has some code, malware when you install it, we're now getting Windows-based apps or stuff that you can easily run that you could trade it yourself over a couple days and do face swaps. And we're going to see that
It's
paired,
already happened, yeah.
that as well as things like 11 Labs are doing voice cloning, right? And so now you're getting people's wrong faces saying the wrong things, and there's no way to track that.
Well, and the bad actor part is a big part of this too. We have to think about that. We have to protect against it, which is why like Glaze and those tools are effective to that. But we also, as individuals, need to be able to support, the industry it is, but also to protect the security of the files that we're dealing with. And it's incumbent on us. And there'll always be bad actors. Understand that. There'll always be bad actors. Pierre, from a developer point of view, how difficult is it for you to set your tool up, which, we're revision effects. First it was Twixter, now with revision effects, you're getting much more advanced capabilities of retiming and redoing things. How much can you do as a developer to be able to do that and keep it safe from misuse?
Do I want?
Do you want to limit the tool to? Yeah. Do you want to limit the tool you put out there to protect it from everybody else?
We've always been like doing morphing and whatever to whatever.
Right.
So it's like.
It's your business model.
Yeah, it's what we do. We do effects. So.
What's Yes, sir.
Since you brought up Twixter, is there going to be a maybe show special on?
Yeah, there is. It's 25% off. You can go to our booth. I might have flyers for you.
It'll last for another week or so. You can reach out online after. So. but the whole process of this is how we teach our models, how we learn to do things, how we as individuals use this technology is pretty sophisticated. But the fact is
I think the first thing is, who spends tons of money training people, like at the top, right? NVIDIA, Facebook, Google, Microsoft, a bit Apple now internally, Amazon. Yeah, that's pretty much where the big holes of that is. I don't know at the individual level, like people doing tools like us. It's like
I'm going to disagree slightly, especially with training models. As of a couple months ago, it was a couple $1,000s. I read Venona, if I believe. They did a 7, 13, 30, and 65 billion models. They were able to train that for under $150.
Yeah.
So
that depends what you're training. So exactly, we do, like for ResUp, we do our own training because it depends. The problem with this sort of, if you start to do, like just I'd use my example, like ResUp. So that's just upscaling, and we're only concerned by photographic material. Of course, it doesn't work with animation, for example. And then you had the noise model, you had the compression model, and now you want to train a joint thing. That's how model grow, right?
Yeah.
And stuff like that. And that's how. So it completely depends what you are training for or something like that.
Well, and using that as a reference, we talk about security cameras and facial recognition and all of that. Those are models that had to be trained. There was an inherent bias in the models they chose in the first generations of surveillance cameras and facial surveillance stuff that was biased towards Northern Europeans. Don't know why, it just was. And then you get into the situation where as the number of faces that are scanned in these environments and they start looping the models back in for a generative knowledge base, you start getting to the point where now all of a sudden there's instead of being a few thousand images, which is what they started with when they started doing facial recognition scans for surveillance, now they're using actually tens of millions of images to be able to align lots of different faces. And that's given because of that model base and because of the inclusion of African Americans and Asians and more women, and then having to do that with people with masks, we're now having to find different ways to train our models. And that's one of the things I think that's really important for all of us to understand is the models constantly need to be trained and updated. You need to be updating the models on a regular basis because the knowledge they grow from a larger model basis is actually really important. And those models help build the knowledge to build newer things.
I have a question. Like Adobe Firefly, like when they released it, part of their marketing was that it's based on Adobe stock, right? So we have permission to do that. Do they have any revenue model for the people that they license stuff?
It's part of the license agreement for the stock usage.
Yeah.
I mean, probably 10 or 12% of Adobe stock is free. So there's that. And there's a lot of illustration in there. What, you didn't know there was free stock in the Adobe stock program?
There's also been, and there's been a lot of backlash online against this, is there are larger companies that you're automatically opted in for any content that you upload is now can be used. Either you don't lose the rights, or it can also be used by whoever that parent company is. So that's I know none of us read the TOS, right? I know all of us are just scrolling down and hitting agree.
It's the EULA, man.
The EULA, pardon me. I was watching too much Star Trek last week, my apologies. But that's something that unfortunately, until we force the manufacturers to say, look, I want to automatically opt out, you're gonna have to go through all of that. And then sometimes you can't even use the service if you don't agree.
Right, and that brings up an interesting point too, is that because right now, Facebook, Instagram opt in automatically as part of their terms of service. Actually, Musk changed it in Twitter too, so it's opted in Twitter now. It's an automatic opt-in in Twitter. And that's one of those things that we as individuals, we as the consumers need to protect against our own rights and the misuse of it from the manufacturers. It's not an easy subject to talk about. It's complicated as hell because it's changing continually. And let's just be honest, anybody who keeps up with what's going on, I tell the story, it's like before I came out to NAB about a month ago, I made a bot that went out and combed the internet for new references to OpenAI, to ChatGPT, to Midjourney, to some of the tools that are out there. And it says, comb anything that's new that hasn't been on before. It's like, great, and in the last month, it's become this ridiculous amount of mainstream data that I can't control. I turned on the bot Wednesday of last week at 7 o'clock in the morning. I shut it off at noon, and it downloaded 10% of the available data and put 20 gigabytes of data machine. That was 10% of the available data that was new that day.
You need AI to parse.
Well, I hadn't gotten that far yet. It's literally, but you start thinking about it, it's like, we're looking at 200 terabytes worth of data that was generated in the last 48 hours on everything that's new. That's how fast this is replicating.
So I saw a conversation by Jan LeCun, who's the head of machine learning at Facebook for a long time. And he said, what creates this acceleration is there's been a movement, which I agree with, like I asked for that for many years, of when you publish a paper, you publish the code with it. Mm-hmm. So this open source code with paper is what creates the acceleration that we perceive right now, or something like that.
I just thought it was funny is about the time that ChatGPT exploded was the same time that Ronald Moore died. The guy from Intel who came up with the famous phrase in the early 60s, that computer technology will get twice as fast and half as expensive every 18 months. With ChatGPT, it's like 18 hours. Every 18 hours.
There's a tool I'd like to recommend that, in complete transparency, is much more geared towards early post-production and post-production more than production. It's a company called Greymeta, Greymeta. Greymeta is what Veritone was what we all thought Veritone was going to be many years ago, which is it has the ability to utilize cognitive services through various providers or their own models to have media analyzed. And it's not just text-to-speech or text-to-captions, it's facial grouping. So instead of feeding it 100 pictures and saying, this is Bob, instead it says, I found all these faces that look alike. Who are they? You say Bob, it's trained. A lot easier. Facial grouping is a lot easier than training. But they also are doing sentiment recognition, right? Happy, sad, angry. They're using metadata of the media files to generate geolocation, right? So they're also generating logo recognition, right? So these are things that are going to make the post-production process easier because instead of searching for whatever the inherent metadata is or whoever logged it, you now can search for Bob sitting on a bench outside in France with a can of Coca-Cola.
Yeah, so there's a personal accumulation of your asset over time, and there's all the company that like television stations like that have the whole archive. So someone dies, find when he scored a goal or whatever, right?
Well, yeah, it's a much more advanced database, and it's defining our future that way.
Yeah.
I find it really interesting too because people like us are doing it, and you did the thing about the logos, and it's like now you can go into some of the software and you just say, gee, go find Bob with the Nike logo and remove the Nike logo in the kind of thing. And that's some of the things. I mean, we're going to talk with Color Lab AI and NVIDIA, and you look at Omniverse and how it's built in there and how the development of that, how the one that keeps getting me and how this is Nerfs. I don't think that people are paying attention enough to what's going to happen in a few years with neural field rendering.
Yeah, so...
and Luma AI in particular, where I can go in and I can set this down on the counter, I can take a series of pictures with it. The AI will take that series of pictures, create a model in 3D that then can be dropped directly into Unreal and lit any other way. Or I can use it in augmented reality, and the environment that I place it in it'll attract the lighting and characteristics of the model I put in, not necessarily what I shot it as. That is fascinating when you understand that that's your phone. And we're not even talking about high-end cinema cameras or anything else, but the phone is going to be the kind of thing that I think a lot of us are going to get the functionality and understanding of how AI works by working with these models and these applications on our phones. And then that will progress to that. Secondarily, I mean, Mike knows this, I'm on the SMPTE committee to help redefine metadata. To high speed, how we handle frame rates, how we handle metadata from cameras and lenses and all of that. Because I see a world, because of virtual percussion, because of AI and how it's going to allow for compositions and color correction and everything else, we're quickly getting to the point where productions and visual effects and all those things are going to be processed in real time in front of us. It's not just going to be the data going to a wall and, the frustum moves a little bit. It's actually going to be understanding in real time what's going on and how it needs to be composited and adjusting depth mask and then adjusting all of the other elements of a visual effects product while we're shooting it live.
I think all of you are going to hate this analogy, but what we're going to see are AI LUTs, right? Mm-hmm. A couple years ago, there was an explosion of, here, buy these 1,000 LUTs that were probably stolen from someone else, but neither here nor there. But you buy these LUTs, and we all know that LUTs are a starting point, right? It's not something you end with. What you're going to start to see are people independently training these models and then selling them or renting them to all of you to accomplish the look to accomplish the job you're looking to do, whether it's generating the text or whether it's generating a picture or video. So that's going to be a very interesting market when you're renting these things. And then folks have to, like marketing agencies, I need to comb through all the footage and find every time a competitor's logo pops up. Okay, so now I'm paying monthly to this company who's uploading or updating these logos every month, and now you're paying yet another service for this monthly.
Yeah. Well, yeah.
So, because just talking a bit about Nerf, right? It's not totally 3D scanning, high quality yet. And in the short run, it's a new, easier way to perhaps build assets too, right? It's like, so there's deviation from the world of asset being disappearing, but reappearing perhaps in another form or something like that, because it implies to do it well, it implies to think about photography, capture, and stuff like that.
I had a discussion yesterday with Sam Nicholson's session, and after he got done, we were talking about Nerfs. And Sam Nicholson is a visual effect artist, ASC member. His company is Stargate Digital. He got into visual effects in the original Stargate movie and built a whole visual effects firm around that. Great guy. He was actually in the session yesterday speaking. And he and I were talking about Nerfs and how he sees the development of Nerfs being the next advancement of visual effects, the next step in visual effects to be able to do that. Because while it seems like those Nerf models are really low res, what we found out with Luma, I just got a new update for Luma, that it actually can do a 2 million polygon surface now. Just in the update that came in the last 2 days on my phone, I pulled it up and it says, these are the new parameters of what it can do. And it's constantly updating content, being able to take objects that we can photograph and build three-dimensional models in it. But then when they built the API to be able to drop it directly into Unreal allowed it to scale because it knows how to accept a model and increase the polygon count to be able to make it higher resolution. Those are fascinating. I mean, you think about what you can do with that in the efforts of photogrammetry for virtual production and what it might be for visual effects.
So that's our little thing like that now. We track drone shot, and it's easy to reconstruct geometry and stuff like that. So it's step by step. I'm still a bit careful about some of the Nerf thing outdoor, stuff like that, with the wind moving, stuff like that. A lot of object removing and putting CG object instead. And some,
it's still a phone app.
It's still but it's still it's an improvement over the old traditional panorama, like photo panel and stuff like that. It's a completely next generation of things like that, at least.
Well, but it's what you showed in your pixel map, where you're actually mapping so much information, and each one of those points of information gives you that much more data to be able to reconstruct the model in a different way and understand that. You had a question? Go for it.
Yeah, I was actually here for the 2016 Nitro 40K.
Haven't heard much about that lately, have you?
Didn't Google buy them?
Google bought the IP. They didn't buy the camera. They bought the IP.
Yeah. They've been on for a while.
A long time, actually.
And on those models, there's also another German company that tried to do on a single lens, multiple view and stuff.
So light field capture, I mean, it's on the iPhone.
Yeah.
Change the depth cinematic.
Yeah.
I guess my two.
It's cinematic mode, but it's not cinema because it's 30 frames a second. I just choke on that every time. Every time somebody says that, it's like, I go swallow a little bit.
So the main point is instead of having a 360 view, right, it's adding an additional degree of parallax, essentially, which you want, or not parallax, but capacity to navigate more around the scene, right?
And I think with the optics, this is really about shadow highlight. So it would be really interesting to see cameras sort of like AI tools, like get you somewhere down to your 7/8.
Yeah. So the problem with camera vendor versus phone is they never they have concerns such as power consumption. That's why they define everything in FPGA. They have very little CPU cycle. It's you go.
Embedded chips for FPGA allow cameras to do what they do, whether it's codecs or anything else, because you're not giving any. You tell the embedded chip that's in there to do this and do this and do this, and that's all, because that reduces the amount of power consumption that the device needs, as opposed to tossing it in a computer and say cycle this and does it work and everything else. That's what Pierre's trying to say. So
the computing. What we're saying too is the computing model is not inside the capture process, right? Kind of start to try to do a bit of that, but the other thing that happened is, like, have you ever tried to synchronize perfectly on a pixel lock basis two cameras, right? I
have. It's not pretty. It is not pretty.
So that's the advantage of those small devices. Have also very short baseline, like a phone. Is very and again, the advantage of the phone is the images isn't. There's a compute cycle available inside of the capture process.
I'd be curious to think what you guys think about, because we all have phones, we're all able to go into a new platform. What do you guys think about AI and ML in kind of the open source community?
I think that's where you're going to see it explode the most, because a lot of the larger creative applications don't want to wade in to a murky ethical situation. There's already been some missteps, right? Adobe's already had some missteps with perceived opt-in, opt-out, et cetera. But open source, I mean, that's why we've seen so many AI ML tools over the past 6 months. And like I mentioned, and there's no hyperbole here, it's the tools I was using a month ago. I'm now using other things because they have incorporated what was done before, make it easier to use. So I think the open source community is really going to be pushing this forward, and luckily you're going to have the NLEs, which are extensible to some extent, will then allow third parties to interact with them, where they can wash their hands of it and say, well, it's not us, it's the third parties.
Well, and let's be honest about where the knowledge base is coming from in all of this. I mean, all of us use content-aware, changes and mapping and corrections in Photoshop. If you work in Final Cut or everything, things like auto binning and those kind of informational things, where it's actually pulling the metadata from a file and it understands enough to process. Okay, this is the same camera clip. This is a clip from the same camera because I can read the metadata of the file, and it's automatically sorting those. That was the beginning of all this. I mean, this is something that's going on in your NLEs every day, or any of your applications. There's already smart tools built into them that are looking at some of this stuff as it is, and helping build a better world for us and making it easier for us, but it also is limiting our creativity, because sometimes it blocks us out. I mean, sometimes some of the models that come up, and content aware is good sometimes. It's not always perfect. Mm-hmm. It has some real issues, especially if you're not working at the size that you want to. Can do some really strange mapping things.
I'll give you a quick story about that. I was talking to a broadcast network in Latin America 2 days ago, and they came to our booth and they said, "Can you do any nudity detection?" And I'm like, "Nudity?" And I said, "Well, that's got to be done." And I went and talked to the Gray Meta folks, and they said, "It's difficult. Anytime you see a bald head, that's a butt." So there are, and he wasn't joking. So there are still some things we don't have models for. So we still have a ways to go. I just made me think of that in terms of Photoshop and content aware. Get rid of the nudity.
It goes back to the picture of the dogs and the muffins. It's the dogs and the muffins. You have to teach these models to understand that, and it's incumbent on us. And all those people who punch through CAPTCHAs just trying to force 3 or 4 of them, and then we found out it's like, oh, wait a second, there's more than just that, and we have to build the models accordingly.
I was talking to someone yesterday. He was dealing with a company that does forestry. They cut trees. Mm-hmm. They drive through the forest with a truck to shooting video, and they tell you that's worth how much money in tree cutting.
Well, I remember talking to some people from Ogilvy and Mather in the UK, and how they wanted to go in and build a 3D model of a forest for a Volvo commercial. So they sent a General Dynamics dog out, one of the dogs out to go with a LiDAR scanner on it, and it mapped the forest. Unfortunately, they forgot to adjust the resolution. And after like 3 or 4 hours, the robot came back, it was actually full, but the resolution would show how you could actually see bugs on the bark of the trees. And it's like, it's not what you need for a car commercial when it's zooming by at 80 or 90 kilometers an hour. It's not what you need. And it's actually understanding these kind of things, because they built this model that was so ridiculously large. It took them 14 days and 3,000 or 4,000 CPU cycles to be able to get it to a usable state where they could actually open a low-res version of it, which was still well over a terabyte. And I don't know if you guys have ever tried to open a terabyte model with a lot of polygons on it, but it does not open easily. So, we've got a few minutes left here. Questions? Yes, sir. Always. Well, you understand that the way you map that out is exactly how we've taught machines to see images. And that's why Photoshop and applications like that are so easy and so quick to be able to replace the sky. It understands instantly where it is. But when you teach a machine to see, the first thing you do is it separates it into a stereogram. The very first process step in OpenVINO and the toolkits I work with is that when it sees an image, it automatically sets parallax. It goes to one extreme and the other and sets parallax in the image so that it can start determining 3D depth even in a still image. And that's the first step in any kind of machine learning of a still image. And then it starts determining based on what it knows. The second thing is it's asked, what's the difference? Is there a sky? And It looks for the shape or an outline of a human. Then
Object
it looks in the planes, the floor plane, side planes, anything else that's in there, and it actually understands all of those, which is one of the reasons why 3D has moved away from traditional photography, because believe it or not, the mapping of the extrapolation of 3D models right now has gotten to the point where it's so much better and so much faster and so much more cost effective than being James Cameron shooting Avatar 2 with real 3D systems. And the cost is amazing. I would not have said that a couple of years ago in the world of 3D, but it has become the case now. It's kind of amazing how we've taught machines to see in a way that actually mimics 3D in that space.
For integrating effects, yeah. So I'm quite familiar with that because if you're doing CG right now, right, you can also burn you can do the distortion at the rendering stage. That's one thing. If you don't want to manipulate your photography, for tracking, like 3D camera tracking, has become very good in they're understanding that distortions in the manner so the 3D tracking is not done. We do a fair amount of that still because we also support all kinds of fisheye and stuff like that. So it depends the amount of distortion. There's also a new lens now that are very rectilinear that people use on purpose, that and they don't look good, right? So you sometimes want, as a look, to have some distortion. So that's very difficult to shoot charts too. But
I'm going to jump all over this one because I just finished doing this to the extreme, because I got hired by one of the lens manufacturers to test internal lens data. Zeiss extended data specifically is what it was, but it was not through Zeiss. And I mapped 185 different lenses from three different rental facilities, same lenses multiple times. You're familiar with Zeiss extended data that comes out?
The Cook i3.
It's /I and LDS and ARRI. There's all different terms for it. But I was specifically focusing on Zeiss extended data, which is a subset of the Cook /4, I/4. And the reality, what I found is that the process of actually creating the charts had so much error in it, particularly in North America, because the first would pull the tape and it gets to within a quarter of an inch, and it's like, yeah, it's a quarter of an inch, that's good. But in my tests of 180 different lenses that did all of this, 99.99% of the lenses were accurate within the witness mark for information and having that distortion information built into the file, which is what was really required for virtual engines and things like that. I found that particularly Zeiss, Fujinon, very specifically, and ARRI and LDS, the distortion measurements and charts and everything they use internally in their optics are actually a magnitude of accuracy greater than what somebody in North America who uses imperial measurements would find on charts. And I mean, just the distances alone, the fractions of that were off. But the things we found out is that with Zeiss extended data and most modern lenses, the margin of error was less than 1/100th of 1%.
Which error from?
Well, it depends on which way you were going, but particularly with a distortion chart, if you don't have it framed perfectly and you don't have it measured to a certain distance, having the information from the camera that's giving me distances in hundredths of a millimeter, we're getting down into microns, not quite microns and things like that, but well within a tenth of a millimeter of accuracy on a lens on where it's focusing and where it's designed to focus. Then you can start finding things with the cameras like shimming problems and everything else. I'm a real big believer that as we go forward in all of this, all of that data is going to be embedded in the lenses and not going to go anywhere else.
Yeah, well, even before embedded, it'd be nice if the target model of the lens was actually published by the lens vendor.
There's actually now, Cook does it. There's a thing called CineMap. Cook has a thing where they actually put a lens on and they map it and they give you a JSON file. Yeah. So you have a JSON file. That's not any good for real-time processing. Zeiss does the same thing with their Cinemap rep. It's really great for traditional post-production. But the reality of it is, with the accelerated rate of what's happening with AI and virtual production and everything, I see the more traditional route for visual effects and post-production becoming greatly reduced in the next 5 to 10 years. Whereas, you'll only be doing visual effects for things that fail or things that are really exotic, but the day-to-day production that we're going to do that has visual effects in it, we're going to do
or integrated into some sort of editing process.
We got about 5 more minutes for some questions here. Anything else? Well, I mean, one of the things that I've talked to people about, particularly with Midjourney, is doing, storyboards and doing Kammes and doing, idea boards and those kind of things that you could use. Here's AI, give it an idea, and it'll give you, I want 10 variations of what the shot might be, and you can go in and tell focal length of the lens, depth of field, cinematic or not, documentary style, lighting styles can all be addicted in there. And now we can start to go from the point where we were doing black and white storyboards to have Midjourney storyboards that are 90% onto the thing. Somebody said, one of the discussions I had over drinks one of the nights with an AI engineer from Google was, he sees it in the not too far future, without regard to the licensing and copyright issues, that you could go in 10 years and say, I want a movie with, Charlize Theron and Harrison Ford. It's a romantic comedy. It's the younger version of him and the older version of her, and they're going to do a romantic comedy that takes place on the desert in winter and kind of thing. And then, 5 minutes later, you have this movie come up based on the script, and I expect to start seeing things like that. I expect to see kids shows. I mean, a lot of people don't realize that the majority of kids shows nowadays are being done in Unreal. They're building them in Unreal because it's far faster than any of the other animation tools.
In real time.
You do in Houdini or Maya or stuff like that. No, you can go in and build the model once and drop it into Unreal, add the mocap to it, and now I've got a real-time animated thing, just like the gaming world. And that's one of the things that I see is how all of the AI and ML stuff is going to happen is this convergence of the technologies we already have, the ideas we already have, and a simpler way to be able to prompt it into existence. That doesn't necessarily make it right or better. It just makes it a way to be able to do more.
I think you're going to see quite a bit of younger talent coming up saying, well, I'll act in your piece for X amount, but I'll license my likeness for less, and then I'll license my voice for less, but I still get a say in what the cut looks like, right? And it'll allow them to do more because they've taken the initial step of saying, I'll do a face scan and then just rent that model out. I hate to use the term LUT, but it will be a body LUT. It'll be an actor LUT. Mm-hmm.
There's just a subset of things that don't work with Twixter, which are very fast motion, right? Which have large occlusion, right? So just kind of simple example I was showing of better, smarter tracking model, right? And we've built internally like segmentation models that separate based on motion, right? To and color, to segment better the object, because we have this problem with a skateboarder or like a snowboarder going fast with the camera moving like that, right? So it comes down to be able to look to understand when it doesn't work, to segment those things, to mosaic something that makes sense in the background, So yes, we've been working on things like that, but it's not in the current version. But yes,
it's a more artificial intelligence application than the typical.
And then
The retiming stuff for that exists in hardware and has for a year. I mean, that's why you
can't really get the pull down look.
Terranex has done it. Terranex has done that in hardware for 2 decades.
Last mile stuff.
Yeah. Well, but even before Blackmagic, Terranex was still the way to be able to do how that frame was.
You're talking about last mile. You're talking about the loop. The Terranex is
Well, no, you do it in post and you work in the same frame rate. No, I ran Terranex all the time. I still have a Terranex for that reason. one of the old style ones. That
Yeah, or you could
I would
use-
retime stuff before post just for that reason.
Yeah, the Cinefilm has Tachyon and Wormhole, which will
right.
do things very similar to that in software.
And Ross has it for broadcast and everything else.
And in software, I think you can do that with our tools right now.
Yeah, a lot of them. One last question, because we got to go. So, go see MJ live in the show here, and you'll see exactly that kind of thing where they've extrapolated what an existing thing and built a hologram out of it and brought him back to life as a stage presence here in Vegas.
You're talking about holographic display?
Yeah, Supersphere, Lucas Wilson has Arc Runner, which was just announced at NAB.
Yeah.
And that does something very similar to that, the kind of virtualized concert experience where you've someone shot on green screen and then in real time, that entire environment can be morphed using Unreal. So that's a little bit of what you're looking for. The audio part you talked about, we are still a ways away from that. There's voice cloning. However, most of the time you're seeing holograms and whatnot, that's a voice actor who's mimicking it. In terms of voice cloning, there are commodity... I'm sorry?
Speech, sorry.
But a lot of those are passable. If you talk to AWS, GCP, Azure, their voice cloning, which is you actually talk to someone and they actually work with you and they train the model, those are good for for call centers. If you have someone, this is the way I like to describe it. If you want a line of dialogue that sounds like Harrison Ford in Blade Runner, right? Deadpan, no inflection, that can be done. But you get someone like Gary, who's very emphatic, and there's highs and there's lows in the voice, that can't be done. And we're still a ways away from that. Now, I totally envision being able to do this inside an NLE and being able to, set up a Bezier curve, and when you do that, you get the inflection in the voice, but it's not there yet.
I thank everybody. Michael Kammes, Pierre, Jasmin. I'm Gary Adcock, and thanks for staying. We appreciate it.